Okay, we had a question about drawing the graph for number 17 and 19 on 6-3. I'm going to do a little bit more than just drawing the graph, just for everybody else that's watching this video too. So the basic idea here is we've got normally distributed data. It happens to have a mean of 100 and a standard deviation of 15. So as soon as we know that it's normally distributed and the mean and standard deviation, as soon as we know those three things, we can draw the normal curve. So normally distributed curves always look about like this. They always have the mean in the middle, so there's 100. And this is a number line along the bottom, so smaller numbers are over here on the left and bigger numbers are over here on the right. We know the standard deviation is 15, so if we go 15 up, we should be about halfway through the upper half. So 115 should be about there, and 130 should be about there. 2 standard deviations takes you almost all the way up. Same thing down this way. There's 85, 15 down, and there's 70, which is 2 standard deviations down. So they want you to find P90, which is the IQ score separating the bottom 90% from the top 10%. So keep in mind bottom or lower numbers on the left, upper numbers, top numbers on the right. So the bottom 90% from the top 10%, we can't be hyper precise about this with this drawing, but we can just eyeball it and say approximately top 10%. Trying to just draw a line here that I think separates about 10% of the area from the other 90% of the area. That's the IQ score that eventually we're going to find here. And if that's pretty much it for the drawing, if you want to do some shading, you could shade in here and just say, okay, this is the 90% of the curve. That's below my area, or below my line that I just drew. So you can say there's 90% there. And if you really want to make it explicit, you can say the other 10% of the curve is right there. Same thing for number 19, for finding the third quartile that separates the top 25% from the others. We'd start with a blank normal curve and fill in the mean and a couple standard deviations if you want to. I don't actually require you to draw the standard deviations for me, but it's good to know the basic idea of where our scale is. In any case, this time we're wanting to separate the top 25% from the others. So 25% is more than 10%. So we're looking at the top quarter of the curve, which again visually to me looks like it's probably about there. And again, if you do want to make it a little more explicit what you're talking about, you would say that's 25% of the curve, 25% of the area, and to the left is the 75%. So that's it for drawing the pictures. I think you said you knew how to do the computational part of it just fine, so I'll stop it there.